Hi students, welcome to the ABK Chemistry channel. See, today we are going to discuss about the reactions of alkyl halides in a single shot. Okay. Now alkyl halides will be involving majorly four types of chemical reactions. Number one is nucleophilic substitution reactions. Number two is reaction with metals. Number three is elimination reactions. Number four is reduction reactions. See, first to come to the discussion about nucleophilic substitution reactions. What are nucleophilic substitution reaction? What the reaction which is initiated by one nucleophile will be substituted by another nucleophile. Such type of chemical reaction generally considered as a nucleophilic substitution reactions. See, in the case of alkyl halides, I am taking ethyl bromide as an example. This ethyl bromide, in this ethyl bromide, what is the bromine is that this is nucleophile. Bromine is a nucleophile. This bromine is replaced by another nucleophile. Those are called nucleophilic substitution reactions. See, in the case of first one, ethyl bromide I taken as a example. Ethyl bromide react with aqueous potassium hydroxide to give ethyl alcohol, to give alcohols with aqueous potassium hydroxide. With sodium methoxide, sodium plus methoxide, and this bromine is replaced by methoxide group. We are getting CH3, CH2, OCH3. CH3, this part is replaced by OCH3. We are getting ethers. So that is ethyl, methyl, ether we are getting. That reaction is also known as Williamson ether synthesis reaction. And next, alkyl halides react with potassium nitrite, to give ethyl nitrite. Why? Because ethyl I taken here, ethyl bromide react with potassium nitrite to give ethyl nitrite. Ethyl bromide react with silver nitrite to give nitroethane. See here, in these two, potassium nitrate and silver nitrate, to give ethyl nitrite is one, another one is nitroethane is one. Both are ambidentate nucleophiles we are called. Both are ambidentate nucleophiles having the same molecular formula but binded with different atoms. In the case of ethyl nitrite, oxygen is binded directly to the carbon atom. In the case of nitroethane, nitrogen is directly binded to carbon atom. Keep in your mind, very important. Number of times they will ask these questions. I mean, this is one important and this one is another important. And next, alkyl halides, ethyl bromide I taken here. Ethyl bromide react with the silver salts of carboxylic acid to form esters here. See, methyl propanoate, this is methyl, this is propanoate, methyl propanoate. We are called simply ester this one. Alkyl halides react with the silver salts of carboxylic acids to form esters. Alkyl halides react with the excess of ammonia. It is also important, students. Alkyl halides react with the excess of ammonia to give a mixture of primary amines, secondary amines, tertiary amines and quaternary ammonium salts. All are nucleophilic substitution reactions. Now come here. Alkyl halides react with sodium thiohydroxide to give ethyl thioalcohol. What we are called? Ethyl thioalcohol. See, alcohol is nothing but CH3, CH2, OH is present. In the place of O, the oxygen atom is replaced by sulfur. Those are called thioalcohols. Methyl bromide react with sodium acetylide. This is called acetylide. Alkyne group is the nucleophile here. This nucleophile is substituted by bromine. So we are getting alkynes, but1-ine. Alkynes we are getting. Alkyl halides react with silver cyanide. Here also it is very important, students, keep in your mind. Alkyl halides react with silver cyanide to give, first silver cyanide I am treating with, to give ethyl isocyanide we are getting. With the silver cyanide we are getting isocyanides. With the potassium cyanide we are getting simple cyanides. Keep in your mind. Here also these two are ambidentate nucleophiles having same molecular formula. In the case of isocyanides, nitrogen is binded to carbon atom. In the case of cyanides, carbon is binded to carbon atom. Keep in mind. With the potassium nitrate to give alkyl nitrites, with the silver nitrate to give nitroalkanes, with the silver cyanide to give the isocyanides, with the potassium cyanide to give the simple cyanides. Very important reactions. 1, 2, 3, 4, 5 reactions. Normally they are asking. Of course, here also, in this case, alkanes case also. So these are all the which type of chemical reactions? Nucleophilic substitution chemical reaction. Okay, students. Already what is the nucleophile is that? That nucleophile will be substituted by another nucleophile. See here, ethyl group is common. In the case of ethyl group is common. Only the bromine group is replaced by, the bromine atom is replaced by all nucleophiles here, all nucleophiles. Okay, so like that, you have to keep in mind. Now come to the next one, reaction with metals. Reaction with metals. Alkyl halides react with metals to give different compounds. Here, two types of compounds, two types of reactions we are going to discuss reaction with metals. Number one is, alkyl halides react with sodium in the presence of ether. Sodium in the presence of ether is nothing but what is that reaction? Woods reaction, keep in your mind, Woods reaction. See, this Woods reaction means number of carbon atoms becomes doubled and we get alkanes. Here ethyl is there, here we are getting butane. At the same time, alkyl halides react with magnesium in the presence of ether to give ethyl magnesium bromide. What is this ethyl magnesium bromide? Grignard reagent. It is a Grignard reagent. See, sodium, magnesium both are the metals. Alkyl halides react with sodium to give the alkanes, that is butane. And this reaction is known as a Woods reaction in the presence of sodium. And alkyl halides react with magnesium to give alkyl magnesium bromide, that is ethyl magnesium bromide we are getting here. So this what are these compounds are formed? Those are called Grignard reagents. That is the reaction with the metals. Now come to the alkyl halides. I take an ethyl bromide here. Alkyl halides involve in elimination reactions are also. That is called Sage-Hoff concept or Jade-House concept. Already we are discussed. Not in the case of symmetrical alkenes here, symmetrical alkyl halides, whatever it may be. Now you have to take unsymmetrical like that. 2-chlorobutane, 2-chlorohexane, like that you have to take. In this case, Sage-Hoff rule we are called. Just leave it, that is another concept. Now here, alkyl halides involve in elimination reaction in the presence of alcoholic potassium hydroxide. Very, very important, students. Alkyl halides react with aqueous potassium hydroxide. Substitution takes place. Which is substitution? Nucleophilic substitution. The bromine is replaced by OH group here. Nucleophilic substitution. Here we are taking alcoholic potassium hydroxide. Aqueous potassium hydroxide, alcoholic potassium hydroxide, both are different. Aqueous potassium hydroxide favors the substitution. Alcoholic potassium hydroxide favors the elimination reaction. Ethyl bromide involve in elimination reaction to give ethene. Propyl bromide involve in elimination reaction to give propane. Like that you have to take. See, alkyl halides are also involved in elimination reactions. Alkyl halides are also involved in reduction reaction. Reduction. What is reduction? Adding of hydrogen or removal of oxygen. Here, what is the bromine atom is there? See here, removal of electronegative atom is also called reduction. Removal of electronegative atom or adding of electropositive element. Here electronegative atom, what is there? Bromine is there. Electronegative atom I am going to removing here. That is called reduction. After adding of hydrogen, one hydrogen I am going to adding to this carbon atom. CH3, CH2 is there. One hydrogen I am added, that will be get the CH3, CH3. That is ethane, CH3, CH3. Reduction of alkyl halides gives all alkanes. Ethyl bromide I taken, in all cases we are getting ethane. What are the reducing agents are favored for reduction of alkyl halides? Zinc copper couple you have to take. Hydrogen in the presence of red phosphorus or zinc copper couple also you have to take here. Tin in the presence of HCl. Nickel or palladium at 525 Kelvin temperature is also. These three conditions are favorable for reduction of which one? Alkyl halides. Like that, alkyl halides are involved in 4 different types of chemical reactions, students. Nucleophilic substitution reactions, reaction with metals, elimination reactions and reduction reactions. These are some chemical reactions. Most of the all chemical reactions will be covered in a single shot. Subscribe and like. Thank you so much.